Hey, what's good, Logan? So coming back at you with another factor theorem video. This is just a continuation of what we talked about the theory. Now we're going to actually apply it. So this is what we got going on. We have to show that the binomial x minus k is a factor of f of x. And then once we do that, we're going to factor it completely. So we're not going to just factor. We're not going to just show that it's a factor, sorry. We're actually going to factor it after we show that. So we start off the problem, by doing synthetic division. So identifying that the k value is -3 for problem 17. So we've identified that the k value is -3, and then we set up our synthetic division. Excuse me, writing down the coefficients of 1, 3. Notice there's no x squared, so we're going to put a 0 up in there, and then -1 and -3. And then we're just going to start synthetically dividing. So we drop the 1 and we multiply. 1 times -3 is 0, -3 times 0 is 0, 0 and 0 is 0. Wow, lots of zeros in there. Another 0, and then a -1, and then a +3, which, yep, gives us a 0. Now, when the remainder is 0, because we plugged in -3, we can identify that this is a factor. So we now know that x plus 3 is a factor of the polynomial. All right, now this problem wants a little bit more than just to show that it's a factor. We want to factor it even further. So we're going to start off, I'm going to start off by showing some of the work here. We know that f of x, which is x to the power of 4, plus 3x to the power of 3, minus x minus 3, has a factor. And that factor is x plus 3. But because x plus 3 is a factor and we divided it, we also have the quotient factor as well, which is x to the power of 3 minus 1. Now our job is to factor this completely, so if we can factor x cubed minus 1, then we need to do so. The good news is, if we recall, that x cubed minus 1 is in the form of a difference of cubes. That means a cubed minus another cube, and it factors. You take one of the a's and you subtract it from one of the b's, and then you multiply it with 2 of the a's and 2 of the b's. And then you combine an a and a b together with addition. So we say plus an a times a b, and that's the factored form of a difference of cubes. So we're going to factor that. So one more time, we're going to take one of the x's and subtract it from one of the ones. And then we're going to take 2 of the x's and we're going to add it to 2 of the 1's, 1 times 1 being 1, and then we're going to multiply the x and the 1, which just gives us x. So we're going to say plus x right there, and then we have the x plus 3 as one of our original factors, and now we have factored it completely. Now some of you might ask, can we factor the x squared plus x plus 1? And when it came from a difference of cubes, you can't, at least not the way that I've been factoring out the difference of cubes. So this right here is in its completely factored form, and we have x plus 3 times x minus 1 times x squared plus x plus 1 is now the factored form of the function f of x. All right, let's try it again, except problem number 18, we have a different factor we want to check, is x minus 6. Once again, we're going to start off with our k value, which is just 6. So I'll write it down, and then we'll get our synthetic division set up. So we set up our synthetic division, and then now we're going to write our coefficients for our polynomial. That's 1, -5, -6. But you'll notice we don't have a linear term, a constant term. So we're just going to put in a 0 right there. And we start off the synthetic division like we normally do. We drop down the 1, and we start multiplying, and that would give us 1, and then 1 times 6 is 6, and that gives us 0, and times 0, and 0, and once again, we find out that f of 6 is equal to 0, which indicates that this is a factor. X minus 6 is a factor. So we can rewrite the polynomial that we have, f of x equals x cubed minus 5x squared. Now, some of you might be looking at this polynomial like, hey, they have an x in common. That is correct. We will have to deal with that in a second. I probably would have dealt with it right at the beginning. But since the problem just says show that it's a factor, I'm going to go ahead and show that guy's a factor first. So we just showed that x minus 6 is a factor. And then we have this resulting polynomial as its additional factor, its quotient factor. And that's going to be x squared plus x with no constant term. Now, x squared plus x has a GCF of just x, so I'm going to go ahead and factor that guy out, and that's going to leave us with x plus 1. And then we have x minus 6 as our original factor. All right, now that kind of looks funny to me. I'm like, that's not how I would write it. So I'm going to kind of separate it a little bit. I'm going to write it the way I would normally write factors. I like to put the factors that don't have any sums, don't have any differences, no addition or subtraction in the front. and then I write down the other factors, the binomial factors, after that. And that's how I would factor number 18. After we have shown that x minus 6 is a factor, we can then factor the quotient polynomial like that. All right, moving on, number 19. So we have x plus 7. That's what we're going to try to show as a factor. That means k, sorry, is negative 7. So we set up the negative 7 and then our synthetic division. This one here has got some nasty looking numbers in there. We got the 3, normal, 4, normal, and then this negative 109, kind of bizarre, and then this 70, a fairly large value right there. Synthetic division, we just go through it. So we drop the 3, multiply to negative 21, and then subtract, that's negative 17, and then we multiply. Of course, if you have a calculator, by all means do it. But 17 and 7 is 119. Subtract that gives us 10, and negative 7 and 10 comes out to negative 70, which is 0. All right, so we now know that the original polynomial of 3x to the power of 3 plus 4x squared minus 109x plus 70, that was the original function, does have a factor of x minus 7. So we're going to write that as a factor of x minus 7. But in addition to having the factor of x minus 7, it also has the factor, the quotient factor, right here of 3x squared minus 17x plus 10. And now we need to factor that guy a little bit further. So we go ahead and look at the quadratic that we have here, and we set up our two parentheses, and we identify the factors of 3x squared as 3x and x, and then we identify the factors of 10, which are 10 times 1 and 5 times 2. Now we're trying to hit 17. I'm feeling that 10 and 1 is going to overshoot us by way too much, or just undershoot us. So I'm going to go with 5 and 2. So I'm going to put a 5 over here and a 2 right there. We can double check. That's 2x. That's 15x. And it says we want to add them together to get the 17, which it does. So we're going to go ahead and get rid of that. We don't need all that work to be shown. And we're just going to put the minus sign on both of them to get the negative 17x, not forgetting the original factor of x minus 7. Now that we have all our linearizations, or all our linear factors, sorry, not linearizations, all our linear factors, we can say, yeah, this guy's done. Now, the only time you can leave a quadratic or a degree larger than 2 is if you don't know how to factor it, and we will talk more about that later. Other than that, ask me any questions in class and hit me up by email. All right, I'll talk to you guys later. Peace.